Great, thanks, Ivan. Before I begin, I have to share something with you guys, and it's been a big burden on my mind for the last week. I had a question on what to wear on stage for my first ever presentation at DevCon. Should I wear a t-shirt? Should I wear a shirt? Should I dress up formally or not? But thanks to Eva yesterday on the rehearsals, she saved my life and gave me the t-shirt for the conference, so I'm wearing that one. The jeans and the sneakers, of course, are mine, so I hope I didn't mess that up. But being after Tashko dressed like that, I doubt that. Anyway, hi everyone, I'm Antonio. The topic today that I'm going to cover is, the title of it is The Hungry DevOps Cookbook, How to Bake Enterprise Solutions. Why the Hungry DevOps? I would say some, if not most of my friends and colleagues will say that I'm always hungry. So I just try to use that in the title. It's not entirely true, but it might be true. So that's me. As Mariana already introduced me, I'm a father of two, a boy and a girl, the boy being a recent newborn of 3 months old. So it's a lot of fun times at home for us. I sometimes DJ. With my buddies, we usually throw some parties on the outdoors and enjoy some nice time and nice music. I practice DevOps as a hobby, not really. I've been involved in this at Tarmac at least for the last 7 years as one of the leads of, I think, around 40 people team of DevOps we have at Tarmac. And I'm also Tarmac CFO, which is actually Chief Food Officer, but not the financial one, of course. We have a different one in that role. So as the CFO of Tarmac, I'm gonna present the menu for today that we have. I actually split it in 3 parts, 3 sections, appetizers, main dishes, and desserts. I use Italian words because I just think it sounds fancy. So all of these, as you can see, connect to a portion of the whole solution that I'm gonna show. Also, I would like to mention, besides kind of showcasing the best practices of all this, this is an example that I'm actually involved in a project for the last 2 years that I'm on, so it's actually a use case that I'm actively working on. Of course, first we'll start with the infrastructure part, and that's going to be the creation of the infrastructure and the bootstrap of it. We use Terraform for this. We create the EKS cluster, the node groups for the cluster, the security groups, IAM roles, whatever is needed, with ISC, which in our case we chose Terraform. That is a module that we actually built in-house and that we store and publish internally in our own GitHub repo. And then it's, of course, used as a child module being pulled for deployment to several different accounts. We have and we leverage the AWS multi-account strategy, which means that we basically have each environment and product in a separate account. I think at this moment is around like maybe close to 50 accounts. Also part of this is going to be the actual bootstrapping of Argo CD in the Kubernetes cluster itself, which is a quite important part because I'm going to cover a bit later a bit more details about Argo CD. That's also done within the same module with Terraform. Of course, we installed the Argo there and all the CRDs and stuff like that so that Argo is present in the later on stages so we can use it for deployment. The module is actually using complex variables and for each maps and loops. By complex variables, I am referring to one big variable that actually has a lot of sub-variables, I would say, underneath, which is an object that inside might contain strings, numbers, booleans, different lists, and some other objects, etc. So this type of approach, I would say, gives you the possibility to avoid duplication of code, of resource blocks code, because let's get an example for like an API gateway integration resource in Terraform. Probably some of you, or if not most of you, know that when we create an API gateway in AWS, we rarely end up with having just one integration or one method. We might need a get, we might need a post, we might need different integration or resources. So having this built in a big complex variable gives us the possibility to just loop through the variable and create all the resources we need with a single block in Terraform. Next, in this initial, I would say, creation of the infrastructure and Bootstrap is going to be, we create an initial IAM role and a Kubernetes service account within the cluster. This is later on used. I'm going to also go a bit more about it in the next slides. This IAM role has permissions for IAM that will allow us to create new roles based on a per need basis. So if we have, let's say, a Kubernetes service or a pod needing access to an S3 bucket, with this role we can create a new specific role only for accessing S3, and by that we also bind to the least privilege access, right? So we, besides actual developers team or DevOps team access least privilege, we also do that in the application part as well. For the backend applications, the architecture is using API gateway, network, and application load balancers. It's, I would say, maybe a not so standard approach, but the use case for this is we needed we actually support several products, and then all those backend APIs, we kind of decided and architected them to be on the same domain, base domain, and then just the difference being the actual path, so the subpath of the domain, and we can achieve that using API gateway. CloudFront and S3, a pretty standard approach for hosting front-end applications. And then we use also HashiCorp Vault, secret token Bootstrap. That is, this token is fetched and fed to the Terraform execution via the pipeline. I forgot to mention that all of this that I'm talking about, like the Terraform creation of the infrastructure, is running in a pipeline, so it's automated. It's not run locally. This token then helps us to have a connection to Vault that we can then later on use init jobs to create a cluster secret store in Kubernetes, and then also create external secrets to connect via the external secrets operator to the Vault and fetch, retrieve secrets in the pods. This slide is something that I'm going to take a bit more time to explain. It's going to show the approach we actually use with GitOps, how we use GitOps with Argo CD, app of apps, and application set. So it's like a mixture of the approaches. The diagram here shows how we actually use this. So basically this part here on the left side, and then also this part here on the right side is kind of covering the same approach, but I split it just to make sure it's meaningful and makes sense to you guys. Of course, in both places, we have the Argo CD application as the base, which is the app of apps, right? Then we use application set behind it, basically. Separation here is on this side, we have like a products application set that we then host, we then create applications in Argo CD for specific product, which will be your applications and code. And then here will be the platform, let's call it the platform application set, which will kind of create and have the Argo CD applications for, let's say, a monitoring stack, Argo CD image updater, external DNS, cert manager, external secrets, anything that you might want to use. This approach is supported, and how we create this is customized. We use customization files and resources. We have split it into like a base and overlays directories. The base is, of course, what basically the word means. It hosts the common configurations across all environments, I would say. And then in the overlays, we have additional directories which are per environment. So there you'll probably want to host like specific environment variables, of course the difference being the Docker images, then some secrets, etc. So you can have as many as you want there in the overlays. Argo CD image updater. This is a quite important part in the whole automation process of how we deploy new images and code. It's deployed, as I showed here, as an application under the platform application set. It is deployed via Helm chart, again with a customization resource. And this is actually the tool that we use to automatically deploy our new Docker images. We're using a digest update strategy, which I'll cover a bit later as well in more details. Helm charts I already mentioned. This is probably well known to most of you here. We use Helm charts for the platform, let's say for the platform application sets applications, like all the external ones, because of course there's something already available there. Cert manager, external DNS, the image updater, with a few tweaks to the values YAML, etc. You can just use it out of the box and don't have to really bother and deploy it on your own. Pre-init jobs with additional service accounts and IAM permissions. This is what I mentioned earlier with the initial IAM role and the initial Kubernetes service account. We use pre-init jobs to create these new IAM roles with specific permissions. I will say the S3 bucket example again. We have a specific service that needs access to an S3 bucket to upload files. We use the initial role we created when the bootstrapping of the cluster happened to create a new IAM role which only has S3 bucket access to the specific resource. Then we, of course, annotate that role in a service account which we use in the Kubernetes deployment service and pod, which will, of course, give the pod access to the S3 bucket we need. Closing up on the appetizers is going to be a little bit of details on, let's say, least privilege and how we handle access. For accessing the AWS console and accounts, we use Identity Center, which was formerly known as SSO in AWS. The IDP for it is Microsoft AD, so we create all the permission sets within the Identity Center with the least privilege access. Again, it's what you need is what you're going to get as a permission, nothing else, nothing more. HashiCorp Vault for the secrets management, and via the external secrets operator I mentioned as well. We store all the secrets in Vault, and then we have, of course, the operator deployed via Helm chart in our clusters that is used to fetch them and use them in the runtime of the pods. Stackator Reloader Helm chart as well. This is a nice tool that enables you to automatically refresh and do a rolling update of Kubernetes config maps and secrets. We use this, of course, for the Vault secrets. This allows us basically to, because an example is whenever you add a new secret in Vault or you actually change a value of a secret of an existing one, the pod itself that's using it is not going to know of it, right? It's not going to just restart on its own. So that's where Stackator comes in help and just does a rolling update, basically just refreshes the pod and creates a new one, which will, of course, then use the new value of the secret. Monitoring stack is Prometheus, Grafana, Thanos, dashboard, and Kubernetes dashboard, pretty standard, I would say. Moving to the main dishes. By the way, thanks to my best man for helping me creating these nice images via Midjourney, so I hope you guys like them. Automated deployment strategy. So let's move to the application part. How we do the deployments in the project is we always automate those, even in production, so we're basically not afraid to deploy to production fully automated. The Docker image tagging strategy here, immutable tags, very important. Please never use only the latest tag on your Docker images. Always have immutable tags because that will help you with the rollback, that will help you with visibility. You will be able to see what code or what actual Docker image you have running in a certain environment. It's very easy to cross-relate that when you have a specific tag. In our case, we use the latest tag, but we also use a GitHub commit SHA tag and also an environment tag, which is dev, QA, prod, etc., depending on the environments. Why do we use the latest? After all, it's because of Docker caching. We use Docker caching in the pipelines we build the new images with. And it's way easier for us. I mean, of course, you can use either of the tags I mentioned for the caching, but it's a bit easier for you to fetch the previous one with the latest tag because it's always going to be just latest and you don't really have to bother to build a logic of oh, wait, what is the latest commit SHA tag, so I can actually pull that one and I'm not mistakenly pulling something else. Docker caching helps, of course, with build speed in the pipeline, and it kind of uses as a base Docker image to build a new one. A little bit of details for the products that we're supporting, and this solution is it's a multiple products with multiple microservices each. This is around like, I don't know, 5 or 6 products at the moment with at least 8 to 10 microservices each. So it's gonna be, I don't know, like maybe 50 pods running only for the products, of course. The technologies is .NET for the backend, and then Vue.js and Svelte framework for the front end. This is all supported by a 4-person DevOps team, and we do several deployments in a day to the lower environment, also supporting and doing several deployments, automated deployments to production in a week. I hope we are still hungry and moving on to the desserts. That's gonna be the test part of it. First step, always local development, right? I mean, this is probably, you're gonna say, this is nothing new, but I just wanted to mention it. Always, whenever you're working on something, new feature or a bug fix or whatever you're working on, just always perform some tests and validation locally. Unit tests, have them always in your code and repo, and always run them inside the pipelines on every push. So whenever you push a commit on a feature branch, even on the main branch, run the unit tests and be sure that you have those validated. Peer review and multiple person approval protection. Whenever you open a PR, even though the tests successfully ran, make sure that you have your colleagues review the PR, and I would emphasize this multiple person approval protection on the branch. Having just one is, of course, okay, but pretty sure all of you have at least one buddy on your team that you can just call and he'll approve the PR even from mobile or whatever. Having 2 is also possible, but it's a bit tougher, so multiple person approval protection is what I would recommend to use in PR merges. This is gonna be last but not least. This is gonna be, I'm gonna cover this with a diagram as well. It's gonna cover the end-to-end testing. How we opted to do all of this is also, again, automated and in a pipeline. It's an integrated and automated end-to-end testing, which runs in a CI/CD GitHub Actions workflow. And how this actually is triggered and runs is via a cross-repo repository dispatch trigger. What I mean by this is we have separation in infrastructure repository, in application code repository, and then in end-to-end tests repository. So it's like 3 different repos hosting each of these components. This also, again, helps with the access and maintenance. Basically, each team that controls these components maintain their own repo and are basically the leads for each of those things. The diagram here shows the process. It's quite big, so I'm just gonna try and cover that on a high-level note. If anyone has any questions or concerns or whatever, feel free to reach out later in the QA. But of course, all starts with the developer in a certain team committing to GitHub. When we commit, I actually forgot when I first made the diagram. That's why it's like the arrow is like this. It's not in this step here, so, but you get the point. Run the unit tests again on every commit. Whenever the PR is ready to be merged, you merge it with multiple approval protection rule, please. And then that will trigger the GitHub Actions pipeline in the application code. Run the unit tests again, success. You're gonna, of course, move to the build process. You're gonna build the Docker image. You're gonna tag it based on your tagging strategy that you wanna use. In our case, we push images to both ECR and GitHub registry. Of course, you can use the registry of your preference. And then Argo CD image updater comes to life. This example shows like a dev deploy and a production deploy. It's a bit simplified, but you'll get the point. I mean, it basically happens the same to the other environments as well. Argo CD image updater is kind of watching, based on the annotation we've set in the application set, is watching the registry, which in our case is ECR, for a new image. And when this is pushed, it says, okay, yeah, I see a new image. I'm going to grab the SHA digest of the image, and then I'm going to update that and with a direct push to the infrastructure repo where we host customization and all those stuff that I mentioned earlier, customization files. Then this specific file in the overlays of the environments gets changed to a new tag. When this happens, Argo CD itself will notice this change in a few moments, depending on the sync interval, of course, and we'll say, yes, there's a new image for the dev environment. I'm going to deploy that right away to the dev EKS cluster. If that is successful, of course, if it's going to basically continue. If not, it's going to just send a notification to Slack in our case. I want to mention that the Slack notifications, of course, are part of the whole flow here. So if there's a failure happening in whichever step of the way, we're going to get notified in a specific channel, depending on which repo it failed in. Dev environment deployed. Additional validations, of course, can be done, but this doesn't stop the pipeline from the dev environment being deployed in the application, in the Kubernetes repo. We then go back to the application code, the application repo, which will then trigger the end-to-end tests. Remember, the end-to-end tests are in a different repository, just the tests, and they also run in a pipeline. And they run, the way we have set them up to run in the GitHub Actions is we use a Minikube cluster. We spin up the cluster in the actions, in the pipeline, deploying all the necessary microservices and with some databases, with some mock data to run the tests. And after and only after those are successful, the actual end-to-end test pipeline will basically kind of come back to the application repository to trigger the production deploy, right, where the code. How that happens is just we pull this same image. By the way, I forgot to mention that the images that we store, we use a single registry repo. So we don't have like a dev repo, a QA repo, it's all one. That's why we're kind of using the additional environment tags to make sure that the flow happens, like first goes dev, we have a dev tag to the image, then end-to-end tests are okay, we move back, we pull the dev image, which of course we want to complete the whole circle to be able to deploy the same image to production. We pull it, just re-tag it with a new prod tag and push it back to ECR. This process here exactly the same as here. Argo CD image updater says, okay, I have a new prod image, I update the digest in the Kubernetes, in the infrastructure repository. Argo CD notices that and deploys to production. This hopefully completes the whole cycle successfully and you're golden. That is all. I would like to thank the organizers and supporters for hosting the event and enabling us to have a nice event where we can discuss and chat about recent and not so recent technologies. Hope you guys enjoyed it. And as the saying goes, they made me do it. I would point any question you might have to my CTO, Brent, who is here actually in the audience. So any questions you might have, you can actually direct them to them. Thank you, guys.
Thank you, Antonio, for this great presentation. Thanks. And I am very curious now if there are any questions, and let's see which ones get directed to his boss. Over here, please go ahead.
Nice presentation, by the way.
Thank you.
I have one question. I see that you're using HashiCorp Vault, but what if you have isolated environment where you can't use something of the cloud's vaults and anything? What will be your second choice, first choice of except .env variables?
By isolated, you mean like on-premise and then
Yes,
you don't have
on-premises.
access to the internet?
Yes, exactly.
Then you'll probably have to use some local storage on the servers running your applications to store secrets. In our case, of course, the outbound access is kind of always enabled, or we tend to whitelist an egress, right, for a specific use case. So that's why we can use Vault or Secrets Manager. But for example, maybe if you host your application again in AWS Cloud, you can use AWS Secrets Manager, right? Even, again, just closing that egress access. But for the on-premise, I'll probably just use something locally on the machine that you find a way to safely upload and store, right, on a server.
Yeah, thank you. That is always the question.
Thanks. I mean, Brent probably should have answered that, but.
Any other questions? Up there, we do have a question, so if we can, for the next question after this one, make the way of the microphone up there.
Yeah, yeah, nice presentation.
Thanks.
I think everything was placed on the table as it needs to be. My question is, on the low level, maybe to add for libraries for a security check is just an add.
Vulnerabilities you
yeah,
mentioned, right?
Yeah, and for code verification validation, something there are some tools, maybe which can improve all these steps and.
Yeah, I didn't put that in my presentation, but we do actually use Chekhov for code scanning, mainly in our Terraform repositories and Terraform code. We also are trying to implement JIT. That's pretty recent, so I cannot really talk about it at this moment, but we are testing it out. Vulnerability scanning, if you mean like maybe Docker image, like runtime or build time, we rely currently on the ECR scanning possibility. So whenever, of course, we push a new image to ECR, we have that scanning enabled automatically, like scan on push. So that gets scanned, and if we have a vulnerability of a, I don't know, high or critical status, we basically get notified. So we try to patch it as soon as possible. So, yeah.
Thank you.
Thanks.
So I'm not sure if we can get the microphone up there, but if you're happy to speak louder, I think that should work just fine. Oh, go ahead.
I always eat healthy, you know, no junk food. Scripts, yeah, we are using scripts. I mentioned the pre-init ones. I think I would say that those are, again, those are all automated, right? So it's nothing running manually or on a machine locally and all that. It's all part of the ISC. So I think that basically, yeah, like script goes, it's the only part we have are the pre-init scripts for creating IAM roles in AWS. That's of course using some AWS CLI commands and stuff like that, attaching policies, etc. So if you're referring to scripts like that, like a bash script or a Python, so I think that's going to be the only place we actually use something like that. Thanks.
We do have time for one quick question. If someone else has a burning question up there, yeah, go ahead if you would like to talk louder.
The light is blinding me, so I was not able to see. I heard the question, so sorry. Oh, up there. Oh, even more. Yeah. Oh, yeah, okay. As I mentioned, so yeah, the end-to-end tests run on Cypress tests. So that Cypress is used for that part. And for the infrastructure part, we don't have any specific like Terraform tests in place. We do have, like I mentioned, Chekhov for scanning of the code analysis and things like that. But at the moment, no infrastructure Terraform tests in place. So that's going to be the answer. Yeah.
And I'll direct all the remaining questions, as usual, for the coffee break. Thank you so much, Antonio. Once
Thanks,
again,
everyone.
a round of applause for the great presentation.